Hey everyone, in this lesson you will be learning how to prove that triangles are similar by using the AA similarity postulate. And this postulate states that if two angles of one triangle are congruent to two angles of another, then the two triangles are similar. For example, suppose we have triangle JKL and triangle XYZ, and the following markings were given to show that angle K was equal to angle Y, and angle J is equal to the measure of angle X. Since two angles of JKL are congruent to two angles of XYZ, we can therefore conclude that triangle JKL is similar to triangle XYZ, so meaning all of their sides would be proportional. And this is by the AA similarity postulate, so we can just say by AA similarity. So maybe we can just use the similarity symbol. In our first example, we're going to try to show that the triangles are similar. So first of all, you want to observe that we have missing angles in both of the triangles, and we can easily find those missing angles by subtracting from 180. So let's go ahead and do that. Subtracting from 180, you get that the measure of angle E equals 64, and the measure of angle K equals 26 degrees. As you can see from the diagram, D and G are both right angles, so obviously that means they're congruent. And we just found the measure of angle E, which was 64 degrees, so we could say angle E is congruent to angle H. So there you have it. You have two angles that are congruent. In fact, we have all three angles congruent, obviously. So since we have two angles congruent, we could say that yes, the triangles are similar by AA. In this next example, you're going to try to show that the triangles given are similar to each other. And a helpful hint is to redraw the triangles separately so that they're not, touching each other or overlapping at all. Just pull them apart and draw them separately. Here's one way that I chose to redraw the triangles. So you can just kind of identify and match up the angles that would be congruent to each other a little bit easier. Alright, so the solution to part A, we can see that the measure of angle A belongs to both triangles. So the measure of angle A is congruent to the measure of angle A, or equal to the measure of angle A, by the reflexive property. So just being really thorough and naming why we can say that, it would be by the reflexive property. But hopefully it's obvious to you that that angle is shared by both of those triangles. Secondly, you can see that the measure of angle C is equal to the measure of angle ABE. They were both given as 52 degrees. So since both of those angles are equal, we have two angles that are equal in both triangles, and therefore we could say that triangle ABE is similar to triangle ACD by the AA similarity postulate. The solution to part B is a little less obvious, so a little more fun. The first most obvious pair of angles that would be congruent is angle SVR is congruent to angle UVT because those are vertical angles. So let's just write that one down. We know that angle SVR is congruent to angle UVT, and this reasoning is vertical angles. So vertical angles. Okay, and then secondly, you should recognize there's a reason why they're telling you that RS is parallel to UT, and that is for you to recall alternate interior angles are congruent. So in this case, we can see that angle S is congruent to angle U, and the reasoning is alternate interior angles theorem. So we can just write by alternate interior angles. Okay, so we have our two pairs of angles that are congruent. So we can conclude that triangle SVR is in fact similar to triangle UVT. And this is by the lovely AA Similarity Postulate. This third example is just really for you to see some standardized test practice, so read it and check it out on your own. Hopefully you can identify that we do need to set up a proportion comparing the following. And in setting up that proportion and solving that proportion by cross-multiplying, you get 40x is equal to 64 times 50, and divide, and you get x equals 80. And that was letter C. Okay, for the following three examples, I'd like you to try these on your own. So just try to determine whether or not you have enough information to show that the triangles are similar. And if they are, make sure you write the similarity statement, meaning write the order of the letters for each triangle correctly. So I'm just going to go ahead and give you the solutions to these, but I do want you to pause the video and try to work them out on your own. Alright, so the first one is yes, there is enough information, and the similarity statement that you want to write is triangle ABE is similar to triangle ACD, or as long as each of those letters matches up correctly in the correct corresponding position. In this second example, we actually don't have two pairs of congruent angles in the triangles. So these two triangles are not similar. In this last example, you need to find the length of segment BC. But first we want to show that triangle ABC is in fact similar to triangle DCE. Okay, so in doing so, hopefully you can identify the vertical angles are equal. So there's one pair of congruent angles. And then we also know that the alternate interior angles, since these are parallel lines, are congruent as well. So there's two pairs of congruent angles, which makes the triangles similar. So now we need to find the length of BC. So first you're going to set up a proportion. I want you to really pay attention here and recognize that segment AC is the segment that corresponds to the side DC on the bigger triangle. So when you're setting up your proportion, you're going to say 5 is to 8 as x is to 12. So pause the video, solve this on your own, and see if you can come up with the correct answer for the length of BC. If you got x equals 7.5, you are correct. Alright, that brings us to the end of this video lesson. Hope you enjoyed. Have a good one.